The reason we need to understand arc to time for calculating LAN is twofold. First of all, it's not a perfect system, and sometimes LAN does not fall on, or the sun is not directly overhead a central meridian at the time that you would expect it to be. Sometimes it fluctuates by a small amount. And then additionally, 12 o'clock is not the time that the sun is directly overhead you. 12 o'clock is the time that the sun is directly overhead the central meridian of your time zone. If you're at 64 degrees west, at 12 o'clock noon, the sun should be just about directly overhead 60 degrees west, not overhead you. It will get to you when it gets to you, and you need to know the difference between the two. So the way the book explains this is it breaks things down based off of MERPAS. MERPAS is, you can see if we come to the daily pages on the sun and moon side, MERPAS is at the very, very bottom. Way down here. Meridional passage right there. Meridional passage is the time of the day in local time that the sun will be directly overhead the central meridian of every time zone. Now, like I said, things fluctuate slightly, but it fluctuates within a day consistently. So if you can see right here, meridional passage is 11:58. If it's 11:58 at Greenwich, local time when the sun is directly overhead, at 60 degrees west, local time, it will also be 11:58. It will be consistent for every time zone. And if you see, we skip to later in the year. Now MERPAS here is 12:05, but it's still 12:05 local time at every time zone, at every central meridian that defines each time zone. Meaning, if you know which time zone you're in, and you know your longitude, you know how far away you are from the central meridian. And because you know how fast the sun moves, you know the difference in time between meridional passage and your times and what it will be at your time. So first, let's practice meridional passage. It's very simple. Let's say, what will be the time of MERPAS on April 3rd. Okay. We skip back. Here's May. April 4th, one more day. April 3rd, which is the bottom. But it's true for all 3 days because there's only one MERPAS section on a page. Actually, it's not true for all 3 days. This is a perfect example. You could see on the first, MERPAS is 12:04. On the second, MERPAS is 12:04. On the third, MERPAS is 12:03. Okay. So every time zone, every single one, it doesn't matter which one it is, meridional passage of the central meridian occurs on this day at 12:03. Now let's say, what is the time of LAN? At 43 degrees, 21 minutes west. On the same day. So we know that every central meridian will base its local time, or will have its meridional passage occur at 12:03. Step one then is we need to know what central meridian we're dealing with. So what zone are we in? What time zone? By the way, for the purpose of this situation, we're assuming that we're not in daylight savings time or anything. But if it were in daylight savings time, you would just skip to the east one time zone. But that's, if that happens, that happens. But right now, let's say we're using our appropriate local time. So we need to find our time zone. The way we do that is we divide the degrees by 15. If we want to be more precise, we convert 21 to degrees, so divide it by 60, add that to 43, and we get our total degrees in just degrees, not degrees in minutes. Divide that by 15, and we get 2.89. 2.89 rounds up to 3. So we're in zone description 3. We're in the west, so it's zone description plus, why did I write the Z? Zone description plus 3. So we're in the third time zone, ZD plus 3, meaning our central meridian, oh, I didn't realize you couldn't see that. Our central meridian is 3 times 15, 45 degrees west. Okay, so now that we know, in our local time, meridional passage will occur at 12:03, and at 12:03, the sun is at exactly 45 degrees west. We are at 43 degrees west, so we're east of there. If this is 45 degrees west, we're at 43 degrees, 21 minutes west. So the sun is over here at 12:03. When was it over us? More simply, was it before or after? It was earlier than 12:03 because the sun is moving this way. So some point in the past, the sun was over 43 degrees, 21 minutes west. How far in the past? Well, that's just arc to time. That's just this distance here converted to how long it takes the sun to move that distance. So the first thing we do is we get our DLO. 45 degrees, 0.0 minutes west, minus 43 degrees, 21.0 minutes west. We carry the 60 over. So we do 60 minus 21 gets us 39.0 minutes. And then we have 44 now, minus 43 is 1 degree. So we're 1 degree and 39 minutes west, or east, sorry, of our central meridian. If we want the time it takes to move this, we just do arc to time, 1 degree and 4 minutes. So we convert this all to degrees. 39 divided by 60 gets us 0.65. So 1.65 degrees times 4 minutes in a degree will get us 2.6 minutes. So LAN for us happened 2.6 minutes before it happened at 12:03. 2.6 we can round to 3, so we could say LAN happened coincidentally, this is amazing, at exactly 1200 in our position. Let's try another problem. Let's say we'll do in the east this time. Let's say on November 20th, what is the time of LAN at $55 degrees, 39 minutes east. Okay. Step 1, we need to find MERPASS. So November 20th, we come to the book, skip all the way, December is too far, October, November 14th, here, November 18th to 20th. We come to the sun page, come down. Here's the MERPAS section. 18th, it was at 11:45. 19th, 45. 20th, it happened at 11:46. So MERPAS happened at 11:46 in every single central meridian. Now we need to find our zone description. So we're 55 degrees 39 minutes east. So step 1, we convert that all to degrees. So we do 39 divided by 60 is 0.65 again. So we're 55.65 degrees east. We divide that by 15 and we get oh, sorry, I screwed up the calculator. 55.65 divided by 15, 3.7, which rounds, sorry, we got 3.7, which rounds to 4. So we're in ZD 4. We're in the east, so it's ZD minus 4. Next, we want to find our central meridian off of that. So our central meridian is the central meridian based off of 4. So it's just 4 times 15 gets us 60. So our central meridian is 060 east. So you can imagine here's 060 degrees east. Here's 055 degrees 39 minutes east. MERPAS happens at 11:46 at 060. The sun's moving this way, so we're going to get LAN sometime in the future. It's going to take some time for it to get, God damn it. It's going to take some time for it to get to us. So now we need to find our DLO. So we're going to do 060 degrees 0 minutes east minus 055 degrees 39 minutes east. Carry the 60, 39 is 21. And then 59 minus 55 is 4 degrees. So our DLO is 4 degrees 21 minutes, which we do 21 divided by 60 is 4.35 degrees. So now our arc to time is 4.35 times 4, because 1 minute every 4 degrees, so 4.35 minutes in times 4, 17.4 minutes. Now we can round it down to 17. 17 is close enough. So we know that this is going to take 17 minutes to go from LAN at the central meridian, otherwise known as MERPAS, to LAN at our position. So finally we do 11:46 plus 17, and we get 12:03. So that is how you find the time of LAN. There are other ways to do this. Some people prefer, instead of finding it off of your central meridian, they find the time it's going to take to go from GM for LAN at GM at Greenwich all the way to you. So it could be, like 12 hours until it reaches you, and then they just convert that from GMT to local time. I don't like that method. I don't even think there's a point in teaching that method. If you want to learn it, you can. This is a lot simpler for me because it's just, we're working with small distances here. We're just going from over here to over here, nice and close. Only it changes the time by a little bit. It should be important to note when we round up or round down, part of that is because this isn't perfect. The purpose of this is so that you can be at 12:03, you can be out there ready with a sextant. Realistically, it should be you're out there ready with your sextant at 1200, maybe 11:57, and you're just sitting there watching the sun, knowing when your clock hits 12:03, you should be absolutely ready to take the shot. Even then, you could see the sun rise or lower a little bit because we were a little bit off because it was 17.4 minutes. So you need to know in person, and I couldn't teach it to you over video, but in person to learn when exactly the sun is as high as it's going to go. But you know it's going to be around 12:03, so that's when you should be prepared for it.